Before we begin, let me give a very brief introduction to what I actually know and how I solve. So for that, first of all, we have two postulates, okay? What does these two postulates says? It says laws of physics should not change the form in different inertial form. The first postulate was this, and second postulate is speed of light is constant in all the inertial frames. So if you have seen in the previous tutorial, there was one equation, wave equation. So under Galilean transformation, this equation was actually changing. It was not having the same form. Okay. So that's why we come up with other transformation called Lorentz transformation, which actually make this wave equation invariant. It does not change the form of this equation. So what is the Lorentz transformation, by the way? So for that, the convention is like this. Suppose we have a stationary frame S and we have one more frame which is moving in along x direction it's moving at speed v with respect to the stationary frame S. And if you denote a point in this denote a point in S prime as x prime, y prime, t prime, and z prime, and if you measure the same point from S, the relation between x and x prime will be like this. So if you do simple Galilean transformation, what will be x prime? X prime will be x minus vt, right? This is the Galilean transformation. Y prime is equal to y, z prime is equal to z, and t prime was actually t in Galilean transformation. But in Lorentz transformation, there is actually one extra gamma factor multiplied with it in x prime, and the t prime is also changed. Similar to this, in place of x prime, we have t prime. So in place of x, we will be writing t. In place of speed, we will be writing the same. In place of t, we will be changing it to x. But this dimension is not matching, so we have to multiply with c square, divided by c square. Okay. So this transformation you have to remember. The same transformation, if you write it for the new coordinates like x, y, z, and t, they also looks like the similar only. So x will be equal to x prime plus vt prime, and there is a gamma here, here y prime, z prime, and here t prime gamma plus v x prime by c square. So you have to remember this Lorentz transformation. Are you guys with me?
Yes, Bhaiya.
Okay.
Yes, Graham.
Hmm. So these transformations are actually used to derive some phenomena called length contraction. So we will be using all these phenomena and transformation. That's why I'm discussing them. So one is length contraction, another one is time dilation. And one more thing you will be getting, which is called velocity addition. This is not yet discussed in the class. It will be discussed soon in the class. So it's like if you have two particles, if you have suppose there is a particle which is going with velocity v in s prime frame, and you know that this s prime frame is also moving in velocity with velocity. Suppose this one is v1, this one is v2. Then the speed of the particle in s frame, if you write in Newtonian mechanics, then we used to write how much? It is simply v1 plus v2, right? Can you guys relate it to it in Newtonian mechanics?
Yes, yes,
Yes,
Bhaiya.
yeah.
But in special theory of relativity, you cannot simply write it like this. This you will see. So, so just note that you cannot write the velocity of particles simply. You cannot add two velocities in STR. There is some formulation. We will get it soon. So the first problem. Light beam is emitted at an angle theta 0 with respect to x prime axis in S prime frame. Okay. 1 second. So suppose we have one S prime frame and there is a beam which is coming at an angle theta 0 with respect to the S prime observer. Now, what will be the angle made by this beam in S frame? Like this stationary frame, this S prime was moving with some speed v with respect to the S frame, and we have to measure what will be this angle as observed from S frame. The question is clear? Anyone having doubt in the question?
No, भैया.
Uh, Bhaiya,
Huh.
in this we need to consider five cases
5 cases? No, no.
because relative velocity here no direction mentioned of relative velocity. So we need to consider one
Okay.
going towards, going away in
No,
x-axis.
no, nothing like that. Because in this one, na, this thing, this one. So here our velocity can be along this also or along this also. If this S prime frame is moving like this, then you have to simply write minus v in place of all the v's. Okay, and we always consider like our S prime is moving parallel to S. Okay, moving parallel to S, and if there is some velocity, either it will be in plus x direction or in minus x direction, unless it is mentioned in the question. Okay, this is the convention we will be using. So if there is some mismatch in the, suppose this is your S and this is your S prime, and your S prime is not moving along this direction but some other direction, then the it will be mentioned clearly in the question that the S prime is moving in this direction.
Okay, so we need not to consider even along y-axis also.
No, no, yes. Okay. The
Okay.
frame speed, frame velocity is fixed to us. That by definition it is fixed, but the particle velocity can be anywhere. Like here in the case, the particle we can say is photon. They are moving along some direction which is making theta 0 with x-axis. So we will be considering that this is xy plane and it is making like this. We are not considering about the z-axis to make it simpler. Okay. Now suppose in S prime we see what is happening in t prime time. Like, so in t prime, so the light will travel some path. Suppose it has traveled some r prime distance, this distance. So what will be this r prime distance? How much distance it will cover?
CT prime.
Ct prime. So we know that r prime is ct prime. Now if you see, the component of this distance along x will be c t prime cos theta, right? Now, suppose we are mentioning two events, like event A when the beam was here, when it has started, and event B when it has reached this point, like when t prime time has passed. So at event A, our x prime A is equal to 0 and t prime A equal to 0. Like we are starting the measurement here, and event B, our x prime v is becoming c t prime cos theta 0, because this angle is theta 0 given to us, so I am writing theta 0, and t prime b I am writing it to be some t prime. This is fine.
Yes, भैया.
Okay, and this x prime and t prime are related to the x and t of s with using Lorentz transformation, so we will be using that. So the distance x in S will be actually equal to gamma times of x prime plus vt prime. Everyone agrees this is the Lorentz transformation. So if you take derivative of this, like if you take some difference, so it will be simply become this, like x2 minus x1 I am writing. So because both of these will satisfy this Lorentz transformation, so we can write delta also. Now what will be the delta x? Suppose in S frame our angle is theta. We don't know if it will be theta 0 or theta. Let us assume that it is theta. It has changed. So the distance covered in S frame in time t will be how much?
CT cos theta.
Yeah, distance will be ct. So distance covered in along x direction will be ct cos theta. Here we have utilized the fact that speed of light is constant in both the frame. Okay. Here otherwise we have, if the particle would have been having some different velocity, we have to write some different velocity. But it's given clearly that this is speed of light we have to use. So that's why we can simply write c here. Ct cos theta. Now Ct cos theta, we can write it as gamma times of t prime cos theta 0 plus v t prime. Okay. Now we have to just simplify. We can use either expression for t or t prime. So let us use the expression for t, c cos theta. So t, we can write it as gamma t prime plus v by c square x prime. So why I am writing like this? So that I can cancel out the t primes. So it will become like this and t prime here. But you know that our x prime is c t prime cos theta 0. So this t prime we can cancel because we have assumed it, we are cancelling them. This gamma we can cancel. So finally you can get that your cos theta will be equal to c cos theta 0 plus v divided by 1 plus v by c cos theta. So the angle it will make will have relation with the previous angle and velocities like this. Anyone have any confusion?
Sir, I
It will
think you
be
missed the C.
here and here. Okay, yeah.
Yes, sir. Okay.
Now if you simplify this, it will look like this. C cos theta 0 plus v by c divided by 1 plus v by c cos theta 0. Now you note one thing. Let me multiply c here, both sides. C cos theta 0 will be equal to c cos theta 0 plus v divided by 1 plus v by c square into c cos theta 0. Now what was c cos theta 0 by the way? It was speed of the particle, speed of light along x direction in S prime frame, right? C cos theta 0 was the speed along x direction in the frame S prime.
Sir, how did you get V by C square in the denominator?
V by c square, wait, I'm multiplying c here, so this part I'm keeping it same, so dividing c here, wait, so dividing c, so it will become 1 here, so this one, and v by c again here, v by c, 1 c I am multiplying here extra, c cos theta, so this by c square.
Okay, sir. I got it.
So v into u x prime by c square. Now this c cos theta was this was not 0. Yeah, this is actually ux. Now if you see it nicely, then you get that speed in x s frame is related to s prime as this. So actually this is the velocity addition formula you will be getting soon in the next classes. Okay, we have done some rearrangement to reach at this step, and this is actually a particular formula, and you have to remember this formula, and you will be taught in the class. So either, so in STR you can start from anywhere until and unless you make some serious mistake, you will reach the correct solution. So even if you start from velocity addition formula or Lorentz transformation, you will reach the same answer. That's what I wanted to say to you. So this question is clear?
Yes, भैया.
Okay.
Yes, Vyam.
Question number 2. So in question number 2, distance between Earth and star is given. So suppose we have Earth here and star here, and this distance is 4.3 light year. Ignore relative motion. Two events A and B occur at t equal to 0 on Earth and 1 year on the star. So two events are given to us, A and B. So position of the event on Earth is 0, and this event is occurring at t equal to 0. And event B, events A and B occur at t equal to 0 on Earth and 1 year on. So event B is occurring here on the star. So position of event B will be equal to how much?
4.3 light.
4.3. And what is the time? It is 1 year. Now you have to note that what is light year, by the way? 1 light year. This is very important.
Distance traveled by light in 1 year. Distance
Distance
traveled by now.
yes, distance traveled by light in 1 year. So if you write your speed of light in meter per year unit and you multiply with this 1 year, then you will get 1 light year. Okay, so 4.3 light year, we can say that it is 4.3 c, and finally the answer will be coming in meter. This is the magnitude it will be coming. Okay, so I'm just writing this. Whenever I will write light year, I will put a c extra. That means our c is actually meter per year unit. Anyway, okay, so next question A. So in A, we have given that an observer is moving from Earth to the star. So there is one spaceship which is moving along this direction with v is equal to 0.98 c. Once you get v, always try to write gamma, and gamma formula is 1 minus v square by c square. This is the formula, and if you put gamma for this gamma will come out to be equal to 5.025 or something similar, approximately this much.
Yeah, yes,
Whenever,
भैया.
okay, so next, calculate the time difference of the events. So what will be the time difference as observed by this spaceship? So how will we do that? We will write what is the time measured by spaceship when this event A has occurred. So this will be Ta prime. So we will write it as gamma Ta minus Txa by c square. Because Ta was 0, Xa was 0, so that's why our Ta prime will be 0. But when you write Tb prime, it will be Tb minus Exb by c square. You know Tb, it is equal to 1 year, gamma equal to 5.025, Tb 1 year, minus V is equal to 0.98c. Now, XB 4.3 light years. So I will be writing it as 4.3 C. So what is the benefit here? Because C square will get cancelled. So finally you can calculate it. So this is in year. So finally, this magnitude will come out to be equal to 16.15 year. Now see, for the Earth observer, the observer on Earth, the events were happening like this. First event A occurs, then event B was occurring. But if you travel through a spaceship with this much speed, you can change the order of the event. For this spaceship, this B event is occurring first, then this A is occurring. This is not intuitive, but you can see if you move this faster, you can actually change some event order. Now, now this occurring of event will actually depend on which direction you are moving. Now you are moving along this direction. In part B, you are asked to find if you move from star to the earth. Now you are moving like this. Will your gamma be changed? No, because it depends only on B square magnitude. Okay, in part C, we have calculate the speed of the spacecraft that makes the trip from the star to the earth in 2.5 years according to this. So now this part is same, right? This velocity is actually just different, opposite. So you just have to put minus v in place of plus v. So if you put it, then your time of A will come out to be 0, but time of B prime will come out to be equal to around 26.2 years. Okay, in B part. But in C, calculate the speed of the spacecraft. We are given that the spacecraft from coming from the star to the earth in spacecraft's frame is taking 2.5 years. Okay, so this is the time. So how much distance the spacecraft will have to cover according to the spacecraft itself? So it will be, if this length is given to us L naught, the distance that spacecraft has to cover is will be basically getting contracted. This length will not be L naught for him, it will be L naught by gamma for him, the spacecraft. Okay. So this distance he will be covering in this much time with the speed v. So this will be the equation. Then from here we have to solve v. Okay. The question is like this: if he has started from here and if he has reached the Earth in 2.5 year, how much? What will be his speed? So this we can do it using like this. Now you measured this v, and you also get that gamma. You got the gamma. Then the next part is, what is the trip time according to an observer on Earth? So you got to know that the clock on the spacecraft measures this much time. So what will be the time measured from the Earth frame? Now you have to get to the proper time. Because this clock was always moving with the spacecraft, so this clock will measure the proper time. So that's why this will be proper time. Okay, proper time is the time in which the clock is moving with the same speed as the observer. So this speed are same. So the time measured on Earth frame will be simply equal to gamma times of this 2.5 years. So this will be the time as measured by Earth to for this spacecraft to reach from the star to the Earth. Okay.
Bhaiya, won't it be divided by gamma? I mean,
No,
the time by spaceship will be less, right? Here, if we see the time measured by Earth will be less.
no. See, this this clock is coming. So it's like this. there is a clock in S prime frame. It is rest with respect to this S prime frame. But
Yeah, yeah.
now suppose the clock is moving with speed v with respect to s. That means our s prime is also moving with respect to v, right? Which
Mhm.
frame we used to call it to be proper frame? We used to call the time measured in s prime it to be proper time, right?
Yeah, yeah.
So that's why we have to write this time, the
Oh, yeah,
time me-
sorry. Oh, I have done
time
same.
measured
I just, yeah, sorry.
yeah, time measured in this frame will be proper time. So that's why we can use time equal to gamma times the proper time.
Yeah, yeah, I got it. I did the same.
Okay. So then the third part. Ravi is on a train of proper length. So we have given that this train is of length L0. Then it is moving at speed V with respect to, so suppose there is some observer S prime which is moving with respect to S at speed some V. Then he fires a bullet from the rear end. So he is standing here. So from here he fires a bullet with speed VB with respect to S prime. Okay. So this is given to us. Now we are asked how much time it takes the bullet to hit from the. So how much time will it take to reach from here to here? This much according to Rita. So from S, how much time will it take? We have to measure. So this we can do again by considering the two events. Like suppose event A, when the bullet is fired from here, and event B when it hits here. Okay. So position of A in X S prime frame will be equal to 0. Suppose we have fired it at t equal to 0. What will be X prime B? This distance, right? Or L0 only. L0 is the proper
Yeah,
length.
L0.
Now this time, how much time will it take to cover this much distance? It was traveling with speed VV. So it will be L0 by VV. This
VV.
much
Yes.
this much time it will take. Now you know all those stuff. Now as with respect to s, we just have to put the formula. With respect to s, we have to measure the time. So we will be writing tb minus ta. It will be gamma times of tb prime minus ta prime plus b by c square xb prime minus xa prime. Okay, once you put it, you will get that gamma L naught by VB 1 plus VB V by C square. This one you can also solve using velocity addition formula. Once you will taught, you try with this formula also. Next part, what is the distance the bullet travels before it hits the front end? According to Rita. So according to Rabi or according to S prime observer, the distance was actually L0, but according to S, it will cover more distance. So we have to measure how much distance it will cover. So it will cover. So if we can measure what is the corresponding XB, then it is done. So XB will be gamma times of XB prime plus V TP prime. So if you just put it, then you will get this much distance it will cover. Gamma L0 is VL0 by VD. Are you guys with me?
Yes, भैया.
Yes, yeah.
Okay. Next, question number 4. So Ravi sees a firecracker explodes at this. So there is one event which is occurring at XA is equal to 1.5 kilometers. After 5 seconds, so we can assume that this event has occurred at t equal to 0. Then after 5 milliseconds, like the event is occurring and it's 5 microseconds. And it is occurring at 100 meters. Now, what is the velocity of Rita with respect to Ravi for whom the firecracker explodes at the same place? Suppose Rita is having some speed v. We do not know if she is going away from Ravi or it's towards Ravi. Now we are given that they explode at the same place. That means we can write that in Rita's frame, x a prime is equal to x b prime. Now once we put this one, then we know that the formula for xa prime and xb prime, gamma times of xa minus vta. Here also gamma xb vtb. So once you simplify it, you will get your v from here. You will get that this time is actually minus of 0.933 C. So we assume Rabi was stationary like this and Rita was moving with V like this, but we got a negative sign. That means Rita was not moving this way, Rita was moving this way. Okay, this just in this question you just have to look at this sentence. Like if they explode at the same place, this will be the equation, then again the transformation relations. Next, which event occurs first according to Rita? So we will be again writing Ta prime how much and Tb prime how much, whichever will be. From here we can get Ta prime is bigger or Tb prime is bigger. From that we can find which event is occurring first and what will be the time interval according to her. Simple, right? So you can use time dilation formula here. You will get the same answers. Next, question number 5. So a pole vaulter has a pole of length L0. So and there is a farmer, he has a shade of length 3 L0 by 4. Suppose he has like that. Now farmer bets that he can shut the doors at both ends of the shade with pole completely inside if the pole vaulter runs at a speed. So this pole vaulter speed is given to us root 3c by 2. So if you convert it to gamma, it will come out to be equal to 2. Now, according to Farmer, the pole vaulter, this pole length will is moving with speed this much. That means this length will get contracted, right? According to Farmer, this pole length will get contracted. And
Yes.
how much it will become? It will become L
L
naught by
by
gamma,
4.
means
Yes.
L naught by 2. Now, because this length, as observed by Farmer, is lesser than his shade length 3 L naught by 4, that means according to Farmer, this pole will fit inside. Okay. Now, when he does it so, he is measuring actually both the end of the rod at the same time. When he is measuring this L naught by gamma distance, this both ends are measuring at the same time. Now, from pole vaulter perspective, if he will see that he has a pole which is having length L0, but the farmer is having shade 3 L0 by 4 proper length, but this shade is coming towards this pole vaulter at gamma equal to 2. That means this shade will get contracted for him, right? Just like the farmer sees this length pole will get contracted. Similarly, pole vaulter will also see that this thing will get contracted and it will become 3 L0 by 8 to him. Now, because his pole is bigger than this shade length, that means he will think that I will not be, my pole will not be fitted inside this. Okay. Now, this disagreement occurs because farmer was actually measuring this pole ends at the same time. When he was measuring Ta prime and Tb prime are actually same. But if you do from pole perspective, then there will be a difference in time actually. He was actually not measuring at the same time. That's why this thing is happening. According to this farmer, this will fit inside, but according to pole vaulter, it will not fit inside. Okay, you try to find what will be the time difference as measured by pole vaulter. then you will get some values like non-zero value. This thing is not happening simultaneously. So the final problem, let's quickly finish it off. So here there is a slab which is moving with speed v, and the refractive index is given to us n, and we shine a laser light from here, and we need to find how much time it will take to this laser light to go from A to B. Okay. So for that, what we can say is the laser will spend some time inside the slab and some time outside the slab. Suppose Ti is inside and T out is outside. Okay. Suppose at event A it is entering the slab, and at event B it is coming out. And suppose x A prime is 0, and what will be x B prime? From this frame, S prime frame, we will see that this distance will be d0, because it is also given that this is the rest frame. In D is in rest frame. So this distance it will cover, this laser beam will cover this distance. Suppose initially time t equal to 0. Now how much time it will take to cross this? It will be distance by speed of light. Speed of light is c by n inside this slab. So this much time it will take. So if S prime calculates it, then he will get that in within this much time it will cover this much distance. Are you guys with me?
Yes, भैया.
So now if we see from outside, then time taken will be equal to gamma times of t v prime plus v x prime by c square. So from here we can get that the time spent by the light as seen from S will be gamma d by c n plus v by c. This much time it will spend outside or inside. Now how much time it will spend in outside region? For that we have to know how much how much distance it has covered outside. Okay, so let us find how much distance it has covered inside. So this much distance it will cover inside, gamma x b prime plus v t b prime. From here we will get that this much distance it has covered inside. So finally outside distance it has covered is L minus xv, and this much distance it has covered with speed c. So this will be the time it will cover outside, and this will be inside the glasses. So total time spent will be equal to L by c. Xv if you put, it will come out to be gamma d by c 1 plus n v by c plus gamma d by c n plus v by c. So you can arrange these values later on nicely. That's it. So first you just check how much time it s from S prime, how much distance it will cover inside and how much time it will cover inside. Then from outside, how much distance it will cover and how much time it will take. From then we can find that this much time it will take in outside and this much time it will take inside. Any confusion?
No, भैया.
Okay.